Through all this today, we'll do the rest tomorrow. So we're going to start with 8.1. We're going to be able to define polar coordinates by the end of today, and then make sure we know how polar coordinates and rectangular coordinates are related. So if we are just going to graph a given polar coordinate, it is going to look similar to this. So r is the distance from, this is called the pole, or the origin. So r is the distance from the pole to the point. And then this is called the polar axis, this line here. So this is always where you're going to start, which is just like if you were graphing on the unit circle. Do you guys remember last year what we called that? It was the terminal side. You always start at the terminal side, and then you're going to go from there. Okay. So this is if you have a positive r value, for if r is greater than 0. Now if r is less than 0, then notice that you are going to have this dashed line component. So anytime it's positive, it would be going towards your theta if you had a positive r value. If you have a negative r value, it's going to be going pi radians away from that. Okay, so it's going to be 180 degrees from this theta value. Now notice that it says the absolute value of r, and that's because you're doing a distance. So your distance is still going to be that many from the origin. Okay, and that's the only thing the absolute value is going to represent here. Okay, but notice that your negative values, your point P, is at the end of this dashed line. Okay, and then some of the notes, you guys already know this, but it's good to refresh our memories that theta is positive if you're going counterclockwise, negative if you're going clockwise. Okay, and then if r is negative, you're going still the same amount of units, the absolute value of r, from the pole, but in the opposite direction of theta. Okay, in the opposite direction. And then I told you to look at figure 4 and draw it on the right. Okay, so this is two different ways that you can represent the same point. So one way would be that your point is r and then theta. Another way you could represent it is negative r and theta. Yep.
So that is r is negative, right? So then for the, so we can figure right what
Wait, say it again.
figure 4 that we drew, that's when r is negative, correct?
This is actually going to be both of them.
So okay, so it,
yeah, so this is going to show the point is r theta,
but then
or
one.
yes, or if you want to call it by the negative name, then the r would be negative, and then the theta value instead of this would be theta plus pi. So instead of going out this way, you would be going back towards this point. So this is going to represent the same point. Okay, and so we're going to do this with the example 1. We're going to end up plotting the points. And it tells you that one is going to have r is less than 0 and the other with r is greater than 0. So if it says r is less than 0, that means that it is going to be negative. And then the other one is going to be positive. Okay, and I'm actually going to do 2 of each to show you how you can get different values. Okay, on your homework, if it says that, you will only have to do 1. Okay, and we're actually going to do steps 1 through 3 with these together first, and then we'll do the rest of them. Okay, so step 1, we're going to draw the origin, the pole with the polar axis. Then we're going to rotate to the given value of theta, and then we're going to label our drawing. Okay, for defining 2 other points, we're going to add and subtract 2 pi to theta for the given value of r. And then for the next point, you're going to replace r with its opposite, and then add or subtract pi. Okay, so it's really important that whatever value of r is given, that's what you're going to add and subtract 2 pi to. And then for the next point, whatever the opposite is, you're going to add and subtract pi to. Okay, so you guys have your protractors on your desk so that we can make some accurate drawings. So we need
Oh, are you closer here?
What's up, future class?
Okay, so yeah, and some of my other kids forgot how to use the protractor, so I'm going to help you. Yeah, you need one? I need it.
Oh, yeah, that's good.
No, I have I have another one. It's just big. Okay, so we're just gonna start. Then you can make this somewhere smaller.
For A?
Yep, for A. So we have 1/2 5 pi over 6. And I like to put some drawing. So you're just going to start with a straight line. Now, if you want to draw 5 pi over 6, first of all, what's 6 pi over 6? That's going to be pi. So if it's 5 pi over 6, pi over 6 is how many degrees? 30. So what's 30 less than 180? 150. Okay, so once you have your line, see how you have the T here? Okay, you're going to put that right on the end of it. So see how my line is lined up with the one that I drew?
Wait, so you draw a line and then?
Yep, yeah, so you have to start with a straight line.
Doesn't matter how long it is. Wait,
Nope.
I'm doing this, is this A?
Yeah.
Okay. There you go.
Okay, and then so it'll be 150 degrees, so I'm just going to make a little point where that is. For some of you, it might be off your paper. That's okay. You can eyeball it. So, like, because if I didn't have enough room, I'm just going to draw, like, this part of it that's on that line here. And then when we label it on our homework, we're just going to label the pole with O. We're going to label the angle here, which is 5 pi over 6. And then this is our point P, which is 1/2 5 pi over 6. Okay, and what we've just done is steps 1 through 3 for part A. Okay, so now what we're going to do is the same steps, but for part B. Yep.
So the 1/2, is that just like make your point B is 1/2?
Yeah, yes. And you're just going to estimate where that is. Okay, now for B you have -4, 101 pi over 2. So 101 pi over 2 is going to be a lot to estimate, so let's think of it like this. Let's see if we can find a simpler angle. So we have pi over 2. Simon, how many times does pi over 2 happen in the unit circle? 4, right? Because it's 90 degrees. Okay, so if it happens 4 times, I can take this and divide by 4. How many times does 4 go into 101 evenly? 25. So what we would have is 25 complete rotations. Yeah, which is the same thing as what? I heard you guys say it. Right? So then if I've done 100 rotations and I end up here, the 101st rotation is going to be here at pi over 2, right? Okay, so when I'm drawing this, I'm going to end up just drawing a right angle, but remember, my R value is what? Negative. So I'm going to draw my right angle like normal. And then instead of putting my point up here where I have the 101 pi over 2, yeah, exactly. I have to use the dash line and then go in the opposite direction, which will be 180 degrees. And then this will be your point P, which is -4, 101 pi over 2. So yes, this is still positive, The only thing that's negative is the -4, because instead of going towards the 101 pi over 2, which is where this is, you're going to go in the opposite direction. Yes.
You don't have to draw it for solid dashed lines. You can
Yes. No, yeah, you have to draw this thing. So it's just like this picture, right? So if this is your negative picture, see how we have all of these? So you have your polar axis, you have the line where theta is, and then my line where r is going to be. Okay, so it'll be just like that. All right, and then let's do C. Okay, so for C, your point is 2, 1. So this is a little bit different. I'm going to do this off to the side first just to jog our memory. So if you are at 90 degrees in radians, that's pi over 2. As a decimal in radians, it's what?
1.57.
Yeah, 1.57. Okay, now half of that is approximately, do you guys know? What's half of 1.5? 0.75, and then half of 0.07 is 0.03, so that would be yeah. Okay, so if I'm trying to estimate where 1 is, and it's completely fine if you do an estimation for this, I'm going to estimate that it's somewhere between the 45 degrees and the 90 degrees. Okay, because it's 1. Probably a little bit closer to the 45 than to the 90 degree line. So again, you can just start with your straight line. So you can just draw any straight line. And then I'm going to estimate, so like I said, I know it has to be bigger than 45 degrees. And it's going to be less than 90, so maybe I want to estimate somewhere around 60. It doesn't have to be exact, so don't worry about that if it's a decimal. So I'm still going to do the same thing where I have 0, which is my pole, my O, my origin. Okay, and then I have my point P here. This angle is going to be 1. And then my point P is 2, 1.
What angle measure are we doing?
1. Oh, so we estimated it somewhere around 60 degrees.
Unit circle?
Like that?
Still? Am I choosing a unit circle?
We will be.
Like, because the whole polar coordinate is based off with radians
Yes.
or degree measures.
Right, so we'll be using it in that sense. Well, and we will be using the coordinates as well in the next thing. Okay, so now that we've done parts 1 through 3, now we're going to do part 4. Okay, so are you guys all set with this? You're estimating?
So remember, this is 1.57 and 18 is 1.57.
Okay, so for step 4, we have to look and see what we're given. So we're given that our R value is positive. So we're going to start with positive 1/2 for both of these. And then you can decide what you want to do. You can either add 2 pi or you could subtract 2 pi. So I'm going to show you how to do both. So with 5 pi over 6, I could add 2 pi to that, or I could do 5 pi over 6 and subtract 2 pi. And to make this really easy so that we can do it in our head is think of 2 pi. If it was over 6, it would be what? Yeah, so if we do 5 pi plus 12 pi, it would be 17 pi. Yeah. Okay, and then if we subtract, if we did 5 pi minus 12, it would be -7, so it's -7 pi over 6. Okay, so either of these points would be fine for when R is positive. Okay, so now we're going to do the opposite one. So the opposite is when R is negative. So for that one, that's when you're going to either add or subtract pi. So this one you always add or subtract 2 pi. This one you're going to add or subtract pi. So now my 1/2s are negative. And I'm still going to take my same value, my 5 pi over 6, and then add pi, and then my 5 pi over 6, and subtract pi. So now, because I have it over 6, I'm still going to be adding, but this time I'm going to add what?
Wait, why are you adding pi?
That. So anytime you do the opposite, you're going to add or subtract pi. Because
Does
it,
it matter which one?
no.
We subtract. Oh wait, no, yeah, that one.
And then so this will be 11 pi over 6. And remember, this is because of the relationship. So like whenever you do the opposite, remember how we saw on the packet, they were always going to be straight across the circle from each other? This is the same thing. That's why we're doing the adding and subtracting pi when we switch the sign. Okay, so now we're going to do the same thing for our part B. So that was part A. Okay, so for part B, we were given that R is less than 0 because what was our R value for B? Yep, -4. Okay, so we had 101 pi over 2. So I'm going to add or subtract 2 pi. Think about what this is going to be over 2. If I'm adding and subtracting 2 pi, it'll be what over 2? Yeah. Okay, so our point is -4, 101 pi over 2. So if I add 4 pi over 2, what do I get? Yeah, 105 pi over 2. Or I can subtract. So if I do 101 pi minus 4 pi, what do I get? Yeah.
Wait, I thought we just said that if R was less than 0, it's just plus or minus pi.
So that will be because we were given the positive. So whatever one you're given, you're going to add or subtract 2 pi.
Oh.
And then the opposite one, you'll add or subtract pi. So like in our next one, we're going to do the opposite. So it's like you're always going to use your given, and then you're always going to do the opposite.
So in A, we didn't actually have to do the one that was where R was negative. You were just showing us.
For A, no, you have to do it in that order because they gave you R was positive. So you have to do it. You have to do this first and this second. For B, your R value is negative, so you have to add and subtract 2 pi.
So it's negative? The X is negative? How do you know?
No, it's your R value. It's whatever you're given. So this is your given point, right?
Yeah.
So see how it's negative?
Yeah.
Okay, so for this one, our given point was 1/2, and this was positive.
So it's your X value.
It's your R. It's your R.
Yeah. It's your X value, but in this situation, we're calling it R. Yeah.
For your polar coordinates.
Why did we do plus 2 pi on B? Because
Because whatever you're given, you add or subtract 2 pi. And then your opposite, you're always going to add or subtract pi. So now for this one, now when we do the opposite, it'll be +4. If I add and subtract pi, this is like 2 pi over 2. And if you have 101 pi over 2, when you add to it, you're going to get 103 pi over 2. Okay, and then if you subtract, we got 99 pies, and apple isn't one of them.
Wait, why is there no apple?
What's that?
Why is there no apple pie?
Because they're all pies. These pies.
Oh, I get it.
Okay, so these are your other 2 values here. Okay, and then we're going to go to C. Now for C, you're given the positive, so you're going to start with that. So you're given the positive value first. So that's when you add or subtract 2 pi. Now this one's actually a little bit special because we have 2, and then if we do 1 plus 2 pi, this is going to be in the simplest exact form, so we're going to keep it just like this.
So it's not over half? Like the Y is... like the 1 doesn't have pi in it?
Right. Yeah. And then you could also do 1 minus 2 pi. So you could do either one of those. Okay. And then, so now when we're doing the opposite, in this case, the opposite is negative. That doesn't have to be the case. It just is for this one. And we could do 1 plus pi, or we can do -2 and 1 minus pi.
Are those the final answer?
Yeah. Yep.
So for homework, we only have to choose one.
Yes. So for your homework, you won't have to add and subtract. You can choose which one you want to
Like our
do.
quizzes and stuff, we can choose.
Yeah,
Also-
unless it says to give me two
Okay.
of them, but yeah.
But we have to still do the opposite, so when R is greater than 0, and
Yes.
R is less than 0, but we have to do 4 points, just 2.
Yes.
Okay.
So like one of each. Yes.
So when it's R is less than 0, it's pi and greater than 2 pi.
Nope, it doesn't matter. It's whatever's given. So that's why we have these directions, right? So to find the other 2 points, you're going to add and subtract 2 pi to theta for the given value of R. So no matter what that is. And then for the next point, replace R with the opposite. So if R was negative, the opposite would be positive. Like you'd have a negative value, which would be positive, and that's when you're going to add and subtract the pi.
Oh, okay.
Okay, so it just depends on whatever your given value is.
So 2 pi goes with the given.
Say it again.
2 pi goes with the given.
Yes. Yep. Okay, so the next thing we're going to learn how to do is convert polar to rectangular coordinates and vice versa. So the way that the polar coordinates are written is with brackets. So whenever you're writing your polar coordinates, you will write them with the hard brackets here. And then anytime it's rectangular, you'll have the soft brackets. So this will be r and theta, this will be x and y. And x is r times the cosine of theta, y equals r times the sine of theta. And then we can also convert from rectangular to polar. So r squared equals x squared plus y squared is going to be helpful. And the fact that tangent of theta is y over x, where x can't be 0, because if x was 0, this would be what? Undefined. Okay, and again, this is your xy to your r theta. Can you please put your phone away, Callum? So example 2, find the rectangular coordinates for the point whose polar coordinates are -4, 5 pi over 2. So whenever you have the polar coordinates, and yours should be, the hard bracket. So that's going to be your r and your theta. Okay? So all we have to do now is go to our conversion coordinates. You already have r and theta. So all you have to do is
Plug it in.
substitute. Yep, plug it in. Okay, so that's what we're going to do. So go ahead and do that for the first one. Okay, so I just wrote x equals r times the cosine of theta. So what was our r value? Okay, and theta is? 5 pi over 2. And then you can use your unit circle to find that value. So if you think of your unit circle, 5 pi over 2 is going to be the same place as what? As pi over 2, right? Because this is 4 pi over 2, 5 pi over 2. So this point is going to be 0, 1. So the cosine is 0 and the sine is 1. So we're going to substitute it in and then simplify. So anything times 0 is going to be 0. Anything times 1 is going to be itself. So then our rectangular coordinates are going to be 0 and then -4. All right, and then for the next one, it says convert the rectangular coordinates to polar coordinates with r is greater than 0 and 0 is less than or equal to theta, which is less than 2 pi. And the first thing we're going to do is use r squared equals x squared plus y squared. And then the second thing we'll do is y over x. Now I highlighted this because if r is greater than 0, that means it's going to be positive. So we are going to take the positive r value. And theta will be in between 0 and 2 pi. So you won't have any negative values. Do you guys have any ideas of what we're going to do first with this equation?
Yeah.
Well, look at your point. You're given a point, and what are those going to be representative of?
R and theta.
No. X and Y. Because how can you tell? Because this is a what kind of coordinate? Yes, it's soft bracket, so it's rectangular, right? So we're going to plug those in for X and Y, and then we're going to solve for R. Okay, so if you plug in -1 and 1, and then solve for your R value. Okay, and then when you take the square root, because we know R has to be positive, our R value is going to be what? Yeah, just root 2, just positive root 2. Okay, now for the second one.
Why do we know it has to be positive? Oh, okay, this says the direction.
Yep, exactly. So the tangent of theta is equal to y over x.
So if it's soft bracket, it's x, y. If it's hard bracket, it's
R theta. Yep. Okay, and then so we have y and x, so it would be 1 over -1, which is just -1. So we're trying to find where the tangent of theta equals -1, except how many places on a unit circle is tangent -1? 2. Okay, 2 places. So this is how we decide which one to use. What we want to do is plot this point, or really, a lot of you are going to be able to look at it and know. So if the x value is negative and the y value is positive, do you guys know what quadrant that is? Quadrant 2, okay? You can also plot it, which I did. So if you plot it, right, you can go over -1, up 1, -1, 1, right? That's going to be in quadrant 2. So in quadrant 2, what theta value do we have for when the tangent's -1? 3 pi over 4. Okay, so now we have our R value and our theta value, and then again, just make sure those are in brackets when you switch it to the polar coordinate. Yeah.
So, you just use the coordinates to determine the quadrant, and then go for that, like the value that we're looking for, so tangent.
Yes. Yes. So tangent will also be -1 in quadrant 4, but because the point is in quadrant 2, we're going to use that value.
Wait, how do you know?
Would it be wrong if we used the one in quadrant 4?
Yes.
How do you know it's 3 pi over 4?
That. So the point at 3 pi over 4 is going to be negative root 2 over 2, positive root 2 over 2. So when you divide them for tangent, you're going to get -1.
And can we do like the reflections if we remember?
Yes. Yes.
3 over 3, 1 root 3.
Exactly. So like at pi over 4, it's 1. So the reflection would have to be the negative. Do you remember that?
And you can use all students take classes too.
Yes. Yes, exactly. Okay, so then I want you to try part B. Yep, so you're trying to find where in quadrant 2 is tangent of theta going to be -1. So if you use your unit circle,
and then you look at the radians of it.
you're going to look at the point. So like tangent's going to be y over x. Well, and also we know here, right, from this, we're going to have, this is 1. So if you do the reflection, then that's going to be
And then you look at the radians.
-1.
Y part.
What's that?
You look at the radians and
The theta, yes.
Okay. Okay, and then for B, Cal, can you put that on my desk, please?
I'll pass, I'm right down with these, I'll check it.
No, I would like you to put that on my desk. Thank you. Okay, so we're going to have the root 8 squared plus root 8 squared. And when you square both of them, what is the square root of 8 squared? That, okay, good. So then 8 plus 8 is going to be, yep, good. And then you're going to square both sides. Good, okay. Now, when you're doing the tangent, what happens when you get the square root of 8 divided by itself? Good, okay. So the tangent of theta equals 1. And then, how do I know this is in quadrant 1? Root 8, root 8. Okay, good. So they're both positive, so it's in quadrant 1. So then we agree theta is pi over 4? Okay, excellent. So then 4 pi over 4 is going to be your final one. Okay? I'm going to go over the last one with you tomorrow. So you guys can skip the problems on your homework. That's take example 4, or if you want to try them, you can.